Now you will see my demo video, and I will start to talk about the procedure of it. At the beginning, the scene is completely dark and there is only one sphere shining in the center. This guy and this first-person character is part of the first-person template in UE4. This room is a hemisphere modeled by a floor and two spheres. One of the spheres is in add mode and the other is in subtract mode. A sphere space can be created by placing a subtracted sphere inside the added sphere. It is like subtracting a smaller sphere inside a larger sphere. Then if the floor is placing across those two spheres, a hemisphere's space is created. So now someone making a sound, the signal will be captured by Max and sent to UE4 through OSC protocol. The aerial word dynamically is 20 dandelions of circle distribution with an initial speed to the word. They start to float in the space. 2 seconds later, data will send to Max as a trigger, and Max will start to play water drop sound. At the same time, the sound explosion blueprint class will be added to the word with the sound wave explosion and disturb the lake, creating wave ripples. Sound input function is easily doing in Max by the ADC patcher. And I do some pre-processing here. Send the OSC data through UDP send patcher. When receiving OSC messages in Max, first we start with UDP receive patcher. It is listening on port 8000. And then it transmits the data to OSC route. It will dispatch data from different sources to corresponding outlets. After receiving some data from Max, radio force component is activated in the engine. It can create radio impulse and force to every actor in a given range. So we can get a sound wave that pushes back all the things. And we can also see a water ripple when making some sound. It is created by an Niagara system of UE4. It is a particle system. The key to wave-like effect is a model called cylinder location in particle span menu. Through this model, we can span all the particles on the cylinder surface. If we manipulate the radius of this cylinder according to the sound input, adjusting parameters and add some effects, the radius will change over time, and from our perspectives, it seems just like water ripples. A sensor is the key component of this project. It is responsible for sensing the collision, responding to it, and sending data to Max. We can see there is nothing shining in initial world because I set the material to pure dark at the beginning. When something hits the sensor, an emissive material is applied on this ring. Another particle system is activated as well. So now sensors has collected data like sensor ID. We can start to create spatial audio. I use ICST patchers for spatial audio. MB monitors can get the location data and show the location on GUI. On the left side is the location of sensors. On the right side is the listener. UE4 can send the locations of listener 10 times per second. If the listener is moving in real world, Max can calculate the relative position of sensors to the listener. So it is a dynamic spatial audio rendering. After we get these locations, they can be sent to encode to encode an ambisonic format. And this route patcher will recognize the ID of sensor to decide which synth will generate a sound.